Hey, it's me, Destin. Welcome back to Smarter Every Day. So you've probably observed that cats almost always land on their feet. Today's question is why? Like most simple questions, there's a very complex answer. For instance, let me reword this question. How does a cat go from feet up to feet down in a falling reference frame without violating the conservation of angular momentum? Now, I've studied free-falling bodies, my own in fact, in several different environments, and once I get my angular rotation started in one direction, I can't stop it. Today, we're going to use a high-speed camera. We're not going to use Allie because this is my daughter's cat. I don't want to hurt it. We're going to use a stunt cat. Let me introduce you to Gigi, the stunt cat. I'll just flip the video vertical and then motion track the cat. It's just going to take a lot more effort in post. We're going to try to do it in a way that doesn't make anybody mad. That's pretty hard to do. You got to drop a cat. Ready, Gigi? Good. Checking out the high-speed data there, Gigi. Okay, the first thing a cat does when it's falling is try to figure out which way is up. It does this either with the gyro in the ear or with its eyes. 3, 2. Ready to talk cat physics? Alright, so check out this footage I captured with the Phantom Miro while Gigi goes to get a drink of water. So here's what's interesting about this to me. If you'll notice at the beginning of the drop, the cat is not rotating. Halfway through the drop, the cat is rotating, and then at the very end, Gigi somehow stops rotating. Newton's first law says that an object at rest will stay at rest unless acted on by an external force. I see no external forces on this cat. So what's happening here? It's not making sense to me. Okay, so in order to really get the right data, we're gonna have to drop her 90 degrees out of phase. Ready, girl? This time, watch your tail. 3, 2, 1. Okay, so you think you figured it out? Check this out. You probably noticed that when the cat was falling, her tail was rotating in the direction opposite of where her body was rotating. What's interesting about that is that that's not how it works. In fact, even bobtail cats can do this. It's called the cat riding reflex. I'll prove it to you. I came across some video from the 60s when the Air Force was researching microgravity for future astronauts. Turns out they took some cats up on parabolic flights. He tries to rotate his tail to flip over, but it doesn't work. He just ends up nutating wildly. Then he does something interesting. He takes his back and he bends it. And when he bends his back and then creates motion, something interesting happens. Ah, now we're getting somewhere. So let me show you one more cat flip with the Miro and we'll figure this out.
Here goes.
Okay, the arched back ends up being pretty important. What he does is he divides his body up into two separate rotational axes that are tilted from one another. When he's released, he pulls his front paws in and does the ice skater trick. He decreases his moment of inertia in the front so he can spin fast up there. But in the back, he pushes his legs away from him, increasing his moment of inertia. So a really large twist in the front equals a really small twist in the back in the opposite direction, and the torques equal out. So as soon as he gets his front paws in under him, all he has to do is extend those legs back out to increase that moment of inertia and stop the front twist, and extend his back legs along that rear axis. That allows him to twist those around really fast, and then all he has to do is pull them back in under his body and then extend all 4 legs and brace for impact. So thank you for your attention. I hope you learned something pretty cool about cats. If you don't mind, woo! Okay, I'm done. If you would, go check out your other cat videos after trying to catch Gigi. Whew, a little too rowdy. If you'd like to, click Gigi the cat to subscribe. We'd appreciate it. I hope you had a good one. And go get the ball. You gotta catch her first. I got it. You want it? Look. Very cool cat. She let us drop her hundreds of times. Or, you know, maybe just 5. Want your ball? Go get it. Click her if you want to subscribe. Oh, but right now we're playing fetch. Ready? Go get it. I'm Destin. You're getting smarter every day. Have a good one. There you go. There you go. You earned it. Let me explain why cats are wizards at physics. First of all, they have physiology working for them. They have no working clavicle like I do, and secondly, they have very flexible backbones. The talent needs a break. 30 centimeters or higher. Anything below that is unsafe. Not that we condone dropping cats. Come here. Come here. Come here. There you go. Come here. Come get in the catapult. 3, 2, 1. Oh man.